Hi, everybody. Thanks for joining our session, Gaming's New Power Couple, Streaming Data and Real Time Analytics. My name is Chase Horvath.
And I'm Sandeep Depare. A brief introduction about myself. I'm a principal solution architect at StarTree. I have been at StarTree for last 3.5 years. I've been part of cloud and big data space for a very long time, and I've had like 21 years of total industry experience. In my role at StarTree, I have been engaging with various customers across different verticals, including gaming, and have onboarded various real-time analytics use cases. I've also authored several technical blogs in this space. Now over to you, Chase, for your introduction.
Thanks, Sandy. I'm a staff solutions engineer at Confluent. I've been working with integration middleware and data pipelines for over 15 years, and I've been an avid gamer for more than double that. So, needless to say, I am very happy to be heading up our gaming team here at Confluent. So, today we're going to talk about the use of Kafka and Pinot in the gaming industry, but that isn't the whole story we have to tell. To understand where we are and where we need to be, we're going to talk about some industry trends. So, what our broad exposure has shown us, because Sandeep and I see a lot of customers. And we'll look at the shortcomings of those conventional wisdoms. And then we're going to show you a better path. We'll show you why it's better. And then we'll wrap it up with a demo. So, let's get started. Setting the stage, it's definitely no mystery that gamers went from an outcast minority to a mainstream majority over the past decade. Maybe what isn't so obvious from the outside looking in is that the gaming industry is having some maturing pains layered on top of a post COVID contraction. Statistically, monthly users and total hours spent gaming are down. We have layoffs, we have mergers, you name it. And some really big and well respected names in the industry have painted a pretty glum picture, and the data, frankly, backs them up. And I would just say the biggest driver of this is post COVID, and that we're no longer stuck at home in our quarantines, and people have more options on how to spend their free time. And while those gloomy numbers definitely don't lie, I would like to say that gaming is not dead. Some markets are definitely maturing from a previous oversaturation, while other net new markets are totally opening up. And I'll just take the Middle East, for example. Like 5 years ago, you could not have convinced me that that would become a major gaming market. But now Abu Dhabi has a government run, government sponsored, driven program to make them into a major gaming industry hub by 2030. I'm talking they are full on planning civic infrastructure and education to make this happen. That's absolutely unprecedented in the gaming industry. That's actually a really cool thing to see, I think. Another interesting metric is who and what games are successful in this environment. And I think it's a good indicator of a healthy market to see that we have success at all levels, and from indie games to AAA studio games. And to me, that means that success is possible and it can be possible for anybody. And then the question becomes, you know, what is actually separating the shrinking number of winners from the rest of the pack?
Successful games and studios follow a formula: build, engage, and monetize. Good game, loyal players, successful monetization. It's all backed by data. No matter how big or small, single player or multiplayer, complex or simple, even silliest simple games are backed by data, and that is getting these three things done. You can't be second rate at this and expect to win. Let's take a step back and look at the traditional standard setup of a data pipeline. On the left, we have data generators. In gaming context, typical data generators are gaming client consoles or game servers or e-commerce applications that generate operational data on a daily basis. This operational data ends up in OLTP databases first. Typically, these are relational databases where the schema is normalized to optimize for write-heavy operations. These could be key value stores or document-driven databases as well if the data is semi-structured. All that operational data is ETL'd into a data lake or a data warehouse where it goes through various steps of transformations. For example, bronze, silver, gold in a medallion architecture. In the end, the true value of data is realized with various analytical use cases such as dashboarding, alerting, or AI, ML, and so forth. Now, here are some of the core activities that are used to drive the build, engage, monetize goals. You can do all these things with that standard setup that we just saw. Uh, but the results are lackluster. Not because the data was specifically incorrect, but because it was late. Let's take cheat and toxicity, for example. If you don't stop that before it can affect other players, people walk away from the game. And this is backed by endless studies. It's not a question. You have to catch it within a few seconds to preserve the community. Game balance, for another example. On launch day, players will find some overpowered ways to play. If the data you use to detect and rebalance that is a few days old, then that play narrowed the window of fun at most important moment in the game history. Let's talk microtransactions and offers as well. These are like commonly used techniques to throw somebody a bone after a bad streak to keep them playing. But if you can't detect a frustrated player before they quit for the day and know exactly the kind of thing that they need and want, then they leave and maybe pick up the game later, but almost never with the offer that you sent them. It's unoptimized revenue attempts. And that, my friend, is spam. How long does it take for you to lock and set down your phone? Like 3 seconds? That is how much time you have to intercept that. And timing really matters in this space.
Right. So we now know the effects of a standard pipeline. Let's look at why the industry standard pipeline isn't delivering success anymore. So, why doesn't this pipeline work? Why do we get the results that Sandeep just talked about? Well, mainly because it's slow. This is the real time analytics conference. You probably knew that was coming, but seriously, like batch after batch adds up to a lot. Customers come to me with anything from like 30 minutes to 2 weeks of latency for analytics results. So let's break down that latency into two parts. Part one would be the time it takes for data to be generated and land in the data lake, where it will then be queried. And then part two is the actual time it takes for the analytics tool to do that query. So in order to get end-to-end latency down as far as possible, both of these must be lightning fast. And that's how you're going to make your biggest impact. So next, this pipeline is unreliable and it impedes business. So there's no enforcement of data schemas. These apps are typically owned by separate teams that hardly communicate. You can't change one thing without breaking the rest, so it's just brittle end to end. And that means any progress is slow and you have lots of downtime. So you aren't delivering the capabilities you need with this pipeline. Closely related to that, just the way this is built means you tend to put data in silos and parallel pipes as a matter, protecting your data and preserving your stability. You kind of keep it to yourself so that no one else can touch it so that you can continue your business operations. Additionally, just in the operational database model, silos are kind of inherent. So you put these two facts together. I got slow change and I've got a lot of silos. And that means you aren't mixing and enriching data as much as you should. So your data is probably pretty low quality and not meeting the needs of your teams, which are constantly changing. So I'm almost done hating on this. This pipeline is also very costly. So the silos, the batches, and the medallion model, all of that leads to a lot of redundant storage, redundant processing, as you have to fix the same data over and over again, and you have waste. Lastly, this pipeline has limited ability to scale, which means it's always sized for peak workloads, as in like launch day, maximum concurrent users, full burn. And then as the game lifecycle continues and players move on to different games, that scales down. But the pipeline doesn't scale down because it's very hard to scale this pipeline down. So then the engineers have other priorities for the next game release. They're not working on this pipeline anymore, and it just kind of keeps burning at that very high scale, very high cost. Those are the issues kind of from a data delivery standpoint. So I'm going to let Sandeep step up and hit this pinata from the analytics perspective.
Thanks, Chase. Oh, Pinata brings back some good and some very bad old memories. Well, batch or even micro batching introduces delays, and these delays are in minutes at the very best, and oftentimes in hours or even days in worst case scenarios. This means you are operating on stale data, outdated model results. And let me tell you, stale data is just one part of the problem. In data lakes, particularly in object store data lakes, storage is decoupled from compute. With that, query latencies are in seconds. And lastly, the number of concurrent queries this architecture can support is very low. It's in single digits. Simply put, this will not cut it for mission critical observability use cases such as cheat and fraud detection or analytical use cases such as matchmaking.
All right. So now we know what is causing these problems. What if we were able to fix them? What if I had up to date data available right now? I'm talking leave everything else the same and actually just make the results faster. So, like magic, all of these core functions that drive our mission become vastly improved. You can stop the haters before their toxicity drives others away. You pair the right people together in a social setting so they have a maximum amount of fun as possible, as fast as possible. And also, your games will stay well balanced for maximum fun and expressiveness. Like, can you imagine if World of Warcraft was just a bunch of damage dealers with no tanks or healers? That sounds really boring, and they definitely would not have just made it to their 20th anniversary. Um, on the monetization side, we talked about sending the correct offer to your players at the point in time where they actually need it. Well, if you can actually do that, then you can stop sending spam to your players and really start engaging in like a mutually beneficial relationship where they trade you money for fun, which is kind of the whole point of this industry, right? It's money for fun. But we just learned that that requires real time. So, how do we get to real time? Well, we use three of the best open source technologies available today. All three of these have had meteoric rise over the past few years. We now have robust groups of contributors and users, keeping them alive, up to date with new features. So, Kafka provides the data transportation and distribution. It's the de facto standard for data streaming and is in use at hundreds of thousands of companies. I think a really important metric there is that 80% of the Fortune 500 are invested in Kafka. Kafka's job is to get data from where it's created to where it's used as fast as possible. That's it at its core. We throw Flink in the mix with Kafka because Flink allows us to do stream processing on those Kafka data streams. That means doing transformations, analytics, and enrichment as the data moves without adding noticeable latency. So it can actually answer many questions in real time while also preparing better, smaller, cleaner data sets for the next step in the pipeline, which is Pinot.
Pinot is the de facto real-time analytics database engine. It is very smartly designed distributed database built on the design principle do more with less. The secret sauce really lies in the variety of indexes and query optimization techniques that it offers. From day one, Pinot was designed to support the scale while meeting the following three technical KPIs. One, provide ultra low query latencies. When I say ultra low, I mean typical query latencies are in milliseconds and almost always in subsecond. Two, support extreme high ingestion rate while keeping ingestion lag minimal. Pinot can easily ingest at the rate of millions of events per second. And the moment that event arrives on that Kafka topic, Pinot makes it queryable in a matter of seconds. And three, high QPS or queries per second rate. We are talking about QPS in the ranges of tens to hundreds of thousands at LinkedIn and Uber scale.
Right. So, where do you get all these amazing pieces of technology? Well, it is all open source, but our customers find value in a fully managed offering from a vendor. So, I am from Confluent. Confluent is the leader in data streaming. Our leadership are the original creators of Apache Kafka, and we are the largest provider on the market. Our other specialty is Flink, because stream processing is clearly an important part of any data streaming story, and Flink is the best tool for that. At Confluent, we offer Kafka and Flink as complete cloud native and anywhere data streaming platform that includes SaaS, self managed, and bring your own cloud offerings.
StarTree is the pioneer of user-facing analytics category. Similar to the Confluent story, our leadership are the original creators of Apache Pinot. For uninitiated, while Kafka was built to support high-scale data streaming at LinkedIn, a sister team at LinkedIn built Pinot to power their 80 plus user-facing analytics use cases while ingesting from Kafka. StarTree is the only provider on the market, and more importantly, one of the biggest contributors to this amazing technology along with LinkedIn and Uber. Working together, StarTree and Confluent have achieved some amazing results powering some mission critical use cases for our customers. Our customers often help us push the boundaries of what these amazing technologies can achieve. A recent engagement at a top 10 video game company is one such example, where we tested a peak ingestion rate of 21 million events per second while maintaining data freshness under 6 seconds at that scale, providing ultra low query latencies under 100 milliseconds, and a query per second rate in hundreds. This particular engagement has involved some cutting, rather bleeding edge innovation. Our customers are more like our partners, and we take immense pride in making them successful. The high level architecture involved collecting players and games metrics data into Confluent Cloud. This metrics data is then ingested and stored in StarTree Cloud, where all the powerful indexes are built. The customers then used StarTree's Grafana plugin that automatically translates user actions into Pinot query language and built some really sophisticated dashboards which are powering their mission critical alerting and dashboarding use cases.
So this is a view of a Kafka Flink Pinot pipeline from a functional standpoint, and it's actually analogous to what we were just talking about, what Sandeep was just talking about at that reference customer. It's a very typical layout with producers on the left and consumer services on the right. But in between, we have Confluent Cloud and that provides the Kafka and Flink. We also provide a robust governance suite to enforce rules on how data changes. Look, that sounds limiting at first, but hear me out. The outcome is that producers and consumers are free to change as needed without the risk of breaking each other. So, with governments, the pipeline is robust and flexible. And also, as a part of a complete data streaming platform, we have many pre built integrations to produce and consume data from popular data sources and destinations. So, that is actually the specific capability we are using to send data to StarTree.
StarTree completes the picture on the consumer side. StarTree ingests data from Kafka in near real time, builds indexes, and stores the data in a highly optimized format for read queries. The beauty of this technology is that you can ingest the data in the raw without losing any grains and still serve it in milliseconds. StarTree offers a variety of indexes out of the box. To name a few, sorted and inverted indexes for faster filtering, range index for range and time series type queries, Bloom filter, geospatial index for location based queries, text index for search queries, and lastly, a specialized index called StarTree index, on which our company is named after. This enables StarTree to power a variety of analytical and observability use cases in the gaming world. To name a few that are listed here: matchmaking, segmentation, real time in game offers, leaderboards, cheat and fraud detection, and something that's not mentioned here: log analytics and metrics observability. Gaming companies consistently push the envelope of the technologies that they use. They move fast, they change fast. Success and failure are hard to predict. To do business in this arena, companies have to be partners as much as vendors, putting the customer first and driving product adoption through capabilities and business practices that work for gaming. Game companies today struggle with bursty workloads due to planned or unplanned launches that can cause capacity swings on a daily basis. Demand for faster time to market, driven by smaller teams, focused skill sets, and rapid development cycles. Global customer reach means the need to support global regulations. And lastly, complicated bleeding edge technologies and high impact on downtime. Confluent and StarTree together offer instant scaling and deployment, fully managed specialized tooling, and pre built integrations, flexible deployment models across all public clouds, SaaS, bring your own cloud, or on prem, depending on your security needs. Looking at this list of needs, you will realize that many of them are what you would expect from a gold standard SaaS product: ease of use, lower TCO, perfect scaling, globally available, and pay as you go.
Right on. So let's wrap this up and see a demo. We talked about the impact of real time data for a select few use cases. And what I want to show you here is a list of use cases that I personally have worked to include Kafka in and thus real time data in as part of the solution. They touch pretty much every function of a gaming company. And the impact I see is not just from the real time aspect, but also from the cross pollination of data streams and honestly better communication between business units because they're having success using each other's data. So they inherently start talking more. Most of these required analytics components to be complete, right? So the pairing of Kafka, Flink, and Pinot is a very natural progression here.
Couldn't agree more. Analytics enables organizations realize full potential of their data. We have seen Pinot powering these use cases at the scale at various organizations. It's a pattern my most successful customers are using as they are able to quickly make features that make big impact on the customers.
Thank you all so much for listening to us. Now for the fun part. We're going to show you Confluent Cloud and StarTree together in action. For the first few minutes, we'll look at data streaming, governance, and stream processing. Then I'll hand it off to Sandeep for a quick look at how simple it is to pipe real-time data into StarTree with our built-in integration. From there, he'll show you just how fast Pinot can provide results over large data sets. Sandeep and I are going to show you the pipeline in action. We'll follow a set of data from producing apps through Kafka and Flink, then to Pinot, and finally to a visualization of that data. We're going to move fast so we can focus on interesting stuff. I'm now looking at the overview of my Kafka cluster. I can see some high-level metrics of data coming in, going out, and storage being used. I'm in the kilobyte per second range right now as these producers are running locally, but this cluster will auto-scale up to gigabytes per second instantly and then back down again if my applications are pushing that much data. And that's kind of the beauty of Confluent. Here I can see all the topics in my cluster and basic stats for each. As you can see, I have 4 topics coming in for game telemetry. And we'll talk about that churn alert topic in a second. Let's take a deeper look at the pipeline for the game tel server topic. So our stream lineage tool allows us to trace data from producer through Kafka topics, through stream processing, and finally to consumers. This is generated by Confluent Cloud and it updates automatically. So here I can see data coming in from my telemetry producer. It flows into the game tel servers topic, and then I can see that it is then consumed by Pinot, which are these consumer groups here, but also by a Flink statement. Let's take a look at that Flink statement. This Flink statement looks at game results and detects players that are losing 3 or more times over a 30-second window. And we're doing this because we think it's indicative of a player about to churn. So not in this demo are the downstream systems that would consume and act on this event in real time to alter the player experience and prevent that churn. So detecting this via telemetry outside of the game server allows us to enrich the experience based on segmentation data for a higher chance of success of preventing that churn. So I'm going to turn it over to Sandeep, who will show you how StarTree Pinot is natively integrating into Kafka to consume these telemetry topics.
Now that we have data published on Kafka topics, let's ingest that in Pinot and make it actionable. We'll use StarTree Data Manager application to ingest the data in Pinot. It provides a 5-step click-through wizard through which you can onboard dataset in minutes. So I'll select Confluent Cloud as connection type, select the game telemetry connection that I have added, which connects to the same server that Chase was showing. I'll select the game telemetry server as the topic here, select the data format, which is JSON, I know that, and click on next. Now we are at step 3, data modeling, which is basically mapping each individual column, input column into Pinot field types between date, time, dimension, and metric, and appropriate data type for that column as well. So this tool has already inferred the schema for you. You don't have to do anything extra here. Click on next. Now, this is a last but very important step where we are defining encoding and indexing for each individual column. Remember, Pinot is a columnar database. So each column, individual column can have its own encoding scheme and indexing scheme as well. Depending on their cardinality, you can choose what encoding scheme to use and also which index to apply. It will depend on what query patterns you want to support. And more importantly, you can apply more than one multiple indexes on a single column as well. Pinot supports that, and that's how Pinot is able to support various query patterns on a single table. I'll click on next. So now this is the review page, which is last step, where it's giving you now quick preview of the data, the schema itself, what that will translate into on Pinot side, and the table config itself. So I'll click on create data set. And at this point, it's making that controller API call to create the table in Pinot. And by the time I finish talking, it has already created. Let's head over to StarTree query console and verify that the table is actually created. And boom, there it is, right? So you can see the data is flowing in already. I'll run a quick count star query to see how many records we have ingested. There you go, 530,000 records ingested. And Pinot actually supports truly real-time ingestion. There is no micro batching involved here. As soon as data arrives on that Kafka topic, Pinot makes it queryable in matter of seconds. In this case, under a second. So you can do some ad hoc exploration here, but I have some more exciting thing to show, which is a real-time dashboard application which I have built using Streamlit. So on that application, I'm pointing to the same topic that table rather that we've created just now, using same Pinot cluster. And I'll just quickly run this now. And there is that real-time telemetry dashboard. It's showing some general insights to start with, like total games played, 530,000. Top players, looks like player 3 is leading the leaderboard right now. Game outcome distribution, win versus loss. Looks like players are winning more than losing, which is great from player engagement perspective. You can also filter by certain time frames, and this is actually firing those queries and loading these dashboards in real time. There is no caching involved in Pinot. You can slice and dice by individual players as well. For example, this player 5 seems to have like 100% win rate, which sounds very suspicious. So you want to figure out what's going on and things like that. I'll clear these filters out. Let's do some more advanced anomaly detection kind of queries here. I'll switch to anomaly detection tab. Now here it's giving me some really important insights. One is like players with unusually high win rate. That player 5 has shown up here again, and it's showing that he has 100% win rate. Again, something to investigate. Also, if there is a there are any low scoring players you want to quickly cater to, you can do that. Like there is a green check mark, so there are no such players in this data set, which is good news. And additionally, if you want to look at slow responding servers, like servers that are reporting lower average scores, maybe because there is a lot of delays on that server, and you want to investigate, maybe add some more capacity to that server or bounce the server simply, right? And lastly, if you want to highlight some challenges with high loss rate, that means players are losing more than winning, and which can cause a lot of attrition. So you might need to balance that game to make it more exciting for the players. That's it from me and Chase. It's been a pleasure presenting to you all. Have a good rest of the session.
Thank you all very much for your time. This has been an absolute pleasure.